Hello.
Yeah, hi Manoj.
Hi, Prashant. Hi, Prashant. How are you?
I'm doing good. What about you?
I'm also good.
Great.
So, Prashant, you okay? You have your lunch and you are, this will be 1 hour interview. So,
Yeah, that's okay.
okay. Okay, Prashant. So, would you like to take this opportunity to introduce yourself and so that we can know each other better?
Sure. So, I'm working as a backend developer right now. So, I have around 6 years of experience and I have worked with three organizations till now. So, I have worked
Mm-hmm.
extensively as a sole individual and I have also worked as a team contributor. So, that means that I have also
Mm-hmm.
worked from scratch on a project and I have also worked on legacy projects. So I'm keen
Mm-hmm.
towards learning new technologies. If there is any opportunity that we can optimize our existing project with new things so that it can improve the performance, then I would like really be interested in that. So that's why I still keep my stack open so that I can get to know new technologies. So that is all about me.
Okay. So you graduated in 2015.
Yes.
Okay. Okay. So, Prashant, why don't you share your screen and video also so that we can start on asking the questions related to data structures, algorithms, and problem solving, whatnot.
Sure. So let me know if everything.
Not yet.
Okay.
Yeah. Now I can see you. Uh,
Okay, I have also shared the screen.
yeah. Now I can see your screen.
Okay, good.
Good. So, Prashant, let's try to solve a problem. We will just discuss the solution for it. We might not be doing actual coding.
Okay.
Uh, we will discuss the solution first, and if we feel that we you kind of have the solution, but you are not able to convey it, then we will go and write the code. Maybe we'll share a screen and write the code for it.
Sure.
Okay.
Yeah, sure.
So Prashant, so let's see. You know about the data structures and all, right?
Yes.
So we have data structures like set queues, right? They support put and remove operation.
Yes.
You so let's think of a data structure which only holds integers number,
Okay.
right? So similar to like your stack or queue or data structure, you have an operation put
Mm-hmm.
which put this number into your data structure,
Mm-hmm.
and you have another method which is
Mm-hmm.
remove that particular number. So if
Okay.
I said put 3, put 2, 1, then I said remove 3,
Okay.
then my data structure will only have two elements, 2 or 1. Does not matter how you save it internally, right?
Got it.
So you understand your put and remove method,
Yes.
right? In a data structure.
Mm-hmm.
And I want you to implement one another method which is generally not in the popular data structure, that is get random.
Mm-hmm. Okay.
So your data structure need to have one more method, get random.
Mm-hmm.
Once a client call this get random method, this get random method should return a random number out of those numbers which are there in your data
Got
structure.
it. Got it.
So if some number is already removed,
Mm-hmm.
a numbers which is already removed, your get random should not ever return that number,
Got it.
right?
Okay.
For get random method, you can use any of the existing library method
Got it. Got it.
that creates a
Sure.
random number from 1 to n,
Mm-hmm.
right? And
Yep.
then you can use that kinds of method for
Got it. Sure.
implementing your get random.
So there are three
But the
methods.
important thing which I need to do is the right. But the constraint that I want you to implement is implement these three method in constant time.
Got it.
So can we discuss the solution for
Sure, sure. I was just thinking about random, but for add and remove, we can talk right now. So, assuming
Mm-hmm.
that we are talking a bit similar to stack, so when we have to add, I
Mm-hmm.
can keep pointers to uh, have a node pointed out that this is going to be the top of the item, and rest of them will keep stored
Mm-hmm.
in an order, as in last in first out, LIFO.
Mm-hmm.
So what we will do is simply we have to have a counter, and we can have stack data structure like stack class. I'm talking about Java right now. So we can use that to add
Mm-hmm.
an item, and it
Mm-hmm.
obviously follows LIFO, so it will have that uh, requirement for us, that is that it will have a top node.
Okay, so when I ask you to remove a number, let's you receive 1374,
Okay,
right? Now I'm asking you to remove one. Can
okay.
it be possible to remove in constant time in stack?
So it won't be. For that, we have to
Right.
use some another data structure like, let's say, array list,
In
because
array list, do we have this functionality to remove a particular number in a constant time?
so it works on indexing. So I think it's O of 1 in that case.
But you don't know the index of the numbers you want to remove,
Okay, yeah.
right?
Oh, yeah, forgot about that.
You added three numbers, and I'm asking you to remove some number. I'm not giving you the index of it.
Got it, got it. Um,
So you have to use internally some data structure
mhm.
so that all these three methods are supported in constant time. You can use more than one data structure also. You can replicate your data as many times as you want. There is no any constraint. There is no space constraint, just time constraint, right?
Got it, got it. What if I use hash table hash map in that case? Or
Yes,
the
you can
data
use.
structure supporting that, which could be a set.
Okay.
So
So
in
how you
that
will use
case,
that?
I can check at, like, when I do dot get. In that case, I can know that this item is there or not, and using
Mhm.
iterator, I can remove it.
So as soon as you are using iterator, your complexity will be off.
Okay, got it. Oh, well.
Right.
Okay, okay,
I'm
okay.
asking to do it in constant time for all the operations.
Okay.
So you are in the right direction. We will have to use multiple data structure inside
Array list and I
to
think
support.
hash map both will be used.
So no, can you think in that direction?
Sure. So let's say if I use hash, so array list will be good for insertion.
So,
That is, for add, we
uh,
will get O
j-
of 1 complexity.
sorry, Prashant. Sorry, Prashant. I'm interrupting you. Will that help if you take a pen or paper? That's okay with this interview.
Oh, okay, all right. So,
Just put your webcam down so that I can see whenever you're writing.
okay. So actually, my
No,
camera
that's okay.
is,
I get it.
yeah, it's
I
not
get
at the
it.
top. That's why.
No, not a problem. Not a problem. I get it.
Okay, so array list is going to be better for insertion. So it will be O of
Mm-hmm.
1 in that case. So for
Mm-hmm.
insertion, I can use array list, and about deletion, I have to think. So for insert, let me first start with insert. So I think insert part is clear, right? Because it will be O of 1.
Right.
So
Right.
what I will do is first, let's say
But
I'm
but do you understand as soon as you are using array list, your insert is sorted. You are saying this, right?
yep.
But
So for
as
that,
long as you are keep using array list, you will not be able to remove. You will not be able to implement remove
okay. So
that.
So
that somewhere point that you are not done with your insert as well, right?
okay, okay,
Maybe you need to think
yep,
rethink
yep.
of insert as well.
So let's say for the insert method implementation, first I'm checking.
Mhm.
Um, First, I'm checking if that element that I'm inserting, let's say item, is already there or not. So for
Mhm.
that, what I will do is I will have a hash map for it. So I'll just
Mhm.
do a hash map, let's say lookup, and if it is able to
Mhm.
find it, that means that I don't have to insert, right?
So
So
you are not using array list now. You are just using a hash map
no, no,
now.
no. I'm using both of them, but let me tell you.
Okay.
So first, I checked if it is in the hash map or not, right? First thing is that.
Mhm.
So if it is not
Mhm.
present, that means it is the first time that it is coming. So in that case, what I will do is I will insert it to the array list, right?
Mhm.
And also
Mhm.
I will insert it to the hash map, or let's say hash table,
So
because that will be really.
what will be the key and value of your hash table?
So for that, let me think. So I can use a constant for a value, and I will keep a key as the item, because here
Key
value,
as the item.
yes, and value can be a constant, which can be anything.
Why?
So
Why?
okay, so
Why you are wasting something? Can you use some other data structure if you need just one element?
okay, we can use set in that case, because it internally uses
Right.
hash map. But okay, I think we
Right.
have to use a value here. I cannot use a constant. So
Hmm.
let me think on that. But meanwhile, just we can keep a note on that, right? Because
Okay.
I'm
Okay.
also thinking as you are suggesting me some kind of scenarios. Okay, so
Mm-hmm.
I will be inserting to the hash table as well as to the array, right?
Mm-hmm.
And
Mm-hmm.
here our key is the item, and value. Uh, so okay, okay, got it, got it. You said we don't know at which index that item is.
Right. When I'm asking you remove,
Yep. So okay,
I'm just giving you the number
okay.
to
So
remove it.
got it. So in that case, I will have the value as index of that
Okay.
item,
Good. Fair enough.
and
Mm-hmm.
for getting that index, I will be using the size of the current array list. So first I'm inserting to the array list, and then I'm going towards the hash map, right? So
Mm-hmm.
when I'm inserting the very first element, the size is going to be 1, and that means that the index
Mm-hmm.
is 1.
Mm-hmm.
Here I'm assuming that index doesn't start from 0, but
Okay.
that will work, right? So
Mm-hmm.
the question I think is answered. So this is all about add, and it is in O of 1.
Mm-hmm.
Okay, let's come down to remove now. Okay, so for remove, okay, we have to know the index first, and to know the
Mm-hmm.
index, we first have to check if that item is in the map or not, right? So I will again have a lookup of that item that we want to remove, if that is inside the hash map or not. If it is, then I will get the index, right? And that index I will remove from my array list.
But how it works, how Java array list remove works, what is the time complexity of that?
So okay, got it.
You are using remove method of array list in Java,
Okay,
right?
okay, 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 okay. Let me think of one another way for that. So if I use remove method, it has to iterate,
Mm-hmm.
and iteration happens when it starts from the start of the list till the end of the list. Okay.
So basically, what Java remove method does, right? You ask, you give it an index and you ask to remove number from that index, right?
Yes.
And it it removes that element and then it do a
Resizes.
reshuffle element.
Yep, yep.
It's
Oh,
and
oh,
then delete
oh.
the last
Got it, got it. So we just have
element.
to
That
stop the
that will
reshuffling. Got it.
right. So this remove method will take order n.
Yep. So if we have to stop the reshuffling, what if that at the first index, then again it has to reshuffle. Yeah. What if the element that we want to remove is at the last uh, of the array list? In that case, reshuffle
Mhm.
will don't have to happen.
Okay.
And and that is not a case for every. So we have to move the item that we have to remove to the end of the list. Okay, and
Okay.
to do that, first I have to find out where that element is, and then I will not remove it. Okay, I can do a swap,
Mm-hmm.
uh, moving
Good.
moving the last element to uh, the element that I want to remove at that position. I will move the last element to that node, to that index, and then do it for the removal one. And then I can, if I use the remove method, it should be O((1).
Okay. Okay. So
Uh,
can you summarize it?
okay, I'm a bit thinking. Okay, so remove method, starting as first, it will check if we have oh sorry, first we have a hash map lookup, and
Mm-hmm.
when we find that key, then we will be able to know at which index it is in the array list.
Mm-hmm.
Then that
Mm-hmm.
index we know, and we know the last index of the array list because that's the size. And then I will do a swap. I can use a temporary variable to do a swap. Um,
Mm-hmm.
it will be efficient. And then after do that,
Mm-hmm.
I will just do remove, and I know the index uh, which is the end of the list, and then I will remove it from there.
Okay. Okay. And now what? What about get random?
Okay, I think that's the trickiest one. Phew, okay, so I can use a random class here, which is obvious, but again, we have to think of a logic. So let's say uh, I know the size of the array list. Let's not guess. We know that the size of the list is, let's say, 10. So we have 0 till 10 indexes that we have to get. So what I will
Hmm.
do is I will use math dot random, and through that I will be able to generate a particular index,
Mm-hmm.
and that index I have to just print, right, that element in get random.
Right.
So
Right.
so in that case we don't have to do shuffling. I can just do get and that index.
Right.
Yeah.
So we are covered all three methods in constant time,
Yeah,
right?
I was worrying about get random for no reason, but yeah.
Get random was easy.
Uh, I think I got confused in between.
Yeah. Not an issue. So how did you find this question? Tough, easy?
Initially, like let's say when we have a problem in an interview, it gets perceived in different way. But eventually, if it
Hmm.
is daily to daily kind of work, I think it will not be a complex problem. It will never be a
Hmm.
complex problem because in interview things changes.
Hmm.
So that's why.
Oh, hmm. Get it. So let's move on to the second problem.
Okay,
Hmm.
got it.
Okay.
Yep.
So you are receiving a streams of number. You are
Okay.
receiving your numbers one by one, and you put them somewhere so that when I ask you to return me the median, you return it quickly.
Okay. So I have a stream of numbers and I have to return the median in,
Right.
maybe less.
So let's say, right. So let's say there are two. So you have an application that exposes two methods.
Okay.
One to get the element from a string, right? So
Mhm.
let's say the number is get, yeah, put, right?
Okay.
So
Yeah.
client will call your put method multiple times. Then it can call get median. So every time get median is invoked, you return the medians of the numbers you have received so far.
Got it.
Then clients may call your put method again after hundreds of time, right? Then again it can call get median. So these two methods are there.
Got it.
Try to implement these two methods that none of them is very heavy.
Okay. So space heavy, right? Or
No,
time
time heavy.
time heavy. Okay. So first we have to put. So again, I can use array list because you said list of numbers, stream of numbers. Sorry.
Hmm.
So for median, I have to. So I can initialize or I can have a global variable as array list, and for add, I can simply use the predefined methods add, and we have
Hmm.
that global list. So what we can do is whenever the client is calling get median, so the current list is obviously going to be called like in an synchronized way. But if there are multiple threads calling out these two methods, then there is going to be problem. So then we have to use
Hmm.
proper synchronization, which is that when they are only getting the array list, we should give a clone or copy of that list so that they cannot do a add to it, and we can use constructor synchronized methods to do the implementation so that they both provide the expected result, not that result that is not in sync. So
Hmm.
that is the implementation here. So I assume that this will get problematic when we talk about multi-threaded environment. Otherwise, this is like we just have to create two methods and that's all.
So yes, let's assume this is not a multi-thread environment. It's
Okay,
just single thread environment.
okay. So get part, sorry, add part is clear. Like I have initial. So let's say I have my custom class in that I have a global variable. Let's say
Hmm.
global list, something like that,
Okay.
and then I'm adding to
Yeah, I
it
get
in my
it.
add method.
Hmm.
So now
Now
I,
come to put.
okay, so I
Sorry, come
just,
to the mid part.
okay, okay. So for median, I have to remember the formula. So let's say there are elements like 1, 2, 3, 4, 5, and 5 by 2 is 5 plus 1 by 2, 6 by 2, 3. That would be 3. So n plus 1 by 2 is going to be the median in this case. So what we
Hmm.
can do is first we have to get the size of the list, the current size of the list. And for that, I will not hold any variable. I will not create any variable which will hold that value globally. I will each time calculate the size using size method, and then I will just do this n plus 1 by 2 formula to get the index that I want to get from the list, right? So again, when we say get from the list, it is O of 1, so it is not going to be bad complexity. So that is going to be the logic.
Hmm. Hmm. But your list is not sorted, right?
So this is unsorted, but does it matter if it is sorted or not? Are you talking?
Median,
Okay, median for median,
median n
median.
plus one
Sorry,
by two
sorry.
only,
Yep. That's the
and
very
one
first
by two only.
requirement. Yeah. Got it. So first we have to sort, and that's also in O of 1, which will be really tricky. So I can use the predefined methods like arrays.sort, and I think it's O of log n. So will that be optimized enough, or do we have to do
Sorry, you are using
arrays?
array dot sort.
Yes, I think
No,
it's
no, no.
log n com no. Okay. Um,
Sorry,
s-
array dot sort time complexity. What you said?
Login.
No.
Uh, and I have to think, but it should be login or even n login.
Right.
Okay. Um, so we have to sort in less time complexity.
Mm-hmm.
Okay. So I cannot use the predefined method in that case because it is not going to be efficient enough. Okay, so I have to create my own sort method in that case. One is not going to be, I think, possible.
No, no. O of one, I'm not expecting also.
I can use sorting algorithms in that case, but quick sort will be the, I think, and login is okay. Maybe login. So I can use heap sort, quick sort, and I think there was one more in that case.
During calculating the median, you are trying to sort the numbers.
First, before actually calculating the median, I will try to do a custom method implementation of sorting the array, and then I will actually do the or what we can do is we can also have a sorted data structure, um, like when it is adding. But again, like I think that will not be optimized enough. So I can use merge sort in this case. Will because again it will be n of log n. But I'm not sure about log n complexity. I think it was quick sort. I'm not sure about that because like I think I'm uh,
Okay,
forgetting
so
that part.
when you are trying to sort in your put method itself,
Yes,
right?
yes,
So every time a new element is coming, you are trying to sort it, right?
yes, yes.
So when you are trying to do that, you will be working on already sorted array, right?
No,
Because
yes,
previously it was sorted. You just want to add a new element,
got it.
right?
Yes.
So
So,
which sorting algorithm will give you better working here? You are
like,
working on a
so actually, I was thinking of a logic which I think will not use any algorithm. So what I can do
Mhm,
is while adding to the list, I can do I can keep a max variable which
mhm.
can be used as a comparable element for each of the elements coming to the array list, and it will just like it will be like we are just doing the reshuffling of the list again and again when there is a new element coming.
Okay.
So I can tell you the logic. So it will be like uh, so let's say if we have only one item inside the list, so I have to iterate over the entire list, and I will try to find out that this current element should it be before the current element or after the current element, right? So I will
Okay.
check if it is greater than or less than.
Mm-hmm.
So depending on that, I will have the index, and that particular index I have to reshuffle the entire list. So again, I think it will be O of n in that case.
Hmm.
So
So adding one element is order of n. So if I needed to add n numbers, it will take n square complexity. If I'm adding n numbers
mhm.
before
Okay,
calling
okay.
get median, it will your your logic will take n square time complexity just because
Yep, yep, got it.
just because you want your get median to be in constant time,
Yes. So
right?
yeah, yep, yep. So one method is really optimized and one is not really.
Right. So can you do something in between because any application that is of this sort of functionality will have more write than read, right?
Got it.
So you are complicating your read method and sorry, you are complicating your write method and optimizing the read one, right?
Got it, got it. I forgot the algorithm that I wanted to use, and I think
Okay.
I will be wasting time in this case.
Okay. Okay. So no issue, Prashant. Uh, so would you like to end with this interview?
Was this the last question?
Yeah, this is the last question. Two questions we generally ask people.
Okay, so then let me think. I thought
So
there will be more.
we have some time.
Yes, okay.
We have some time.
So I can provide of n, then it will not be good because it will be O of n square. So n log n is not going to work.
Just a hint, Prashant.
Yeah,
Are you aware of binary search tree?
a BSTS.
Right.
Okay, okay, got
So
it.
if we start putting all the incoming number in BST,
Got it.
so can you say the root will be the median?
Because
Uh,
like the elements has to be greater than left side, it will be less than, and right side will be greater than the root node, and it will keep at it.
so
So we will
so this will be your median. Root will be your median in case your binary tree is balanced.
in yep, yep, if that is balanced. Yep. So
But
yep,
if you
okay,
are getting a random stream, that stream may not create a balanced binary tree.
got it, got it. Because like I was thinking of using the sorting algorithms only, and they will provide n square in that case.
Mhm.
Okay.
So
Yeah.
not an so you can't sort number lesser than in order n, right?
Yes. I can do.
So
I think.
sorting
Yep. 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 Log n will
so so
be.
so having so, so having a creating a sorted list as you go and put the numbers is not a solution, I guess, right?
Yes.
So we just discuss, let distribute the workload. And if you are trying to do it somehow in the put method to get a sorted list in the put method itself, then basically you are optimizing your get median method. Your get median method is constant time complexity,
Yes.
right?
Yep. Yep.
And sorting a list in order and time, I think this is the best you can achieve,
So sorting a list in order, like in median method.
right?
Okay. So what if we don't actually create a list? We create BST. Because like if we can check if it is balanced or not later on, but we will keep
Mm-hmm.
adding to it because like you said, space is not an issue.
Right.
Uh,
Right.
so we can maintain that, and if the tree is balanced, in that case we know, and we know the root, and we
Mhm.
can return the median in O of 1 in that case.
Right.
So
And
yep,
what if not balanced?
in that case we have to find out. So that will be okay. Let me let me think a bit more on this.
Mm-hmm.
So in that case, we can just do a count of nodes. Like let's say if it is balanced, then it will be even, right?
Mm-hmm.
And in that case, we know. Okay, let me think. Uh, yep, yep, yep. So n by 2, n plus 1 by 2 is going to be the median.
Right. Then at least you achieve n complexity in your put method and complexity in your receive method, right?
But if there are n elements that we are trying to insert to the BST,
Mm-hmm.
then
So what is the n complexity of inserting in BST?
O of 1.
Insert in BST. It's not necessarily that you will find the place where to insert in constant time, right? Sometimes you have to navigate through your binary search tree. You check your root is greater or smaller. You
Yep, yep,
find
yep.
that it is smaller. You went
So,
to the left,
yep,
right
yep, yep.
subtree,
So it is
right?
n O of n in that case, and oh, sorry, O of
Uh,
log n,
oh,
log n, log n, log n. Sorry,
right.
and it will be n of log n in that case if we are inserting n.
Putting n methods, n elements,
So it is,
putting n elements become n log n.
so it is less than n square. So that will be more efficient.
Right.
Got it.
And somehow if you could create, now that part is sorted. And if you spend some time and find if that help you to get median easily, then that again we will be good, right?
Yep, yep. Got it.
Instead of constant time, maybe we can try to get the median in log n time. Log n time is also very small, right?
Yes, yes. So yeah, so we can, yeah, I think this is good enough because BST will be like worst case scenario of addition will be n log n, and worst case of median, finding median will be O of n.
Right. So you are talking about worst case, right?
Yes.
So give, give a thought and tell me, creating the binary search, putting your numbers in binary search at worst case is what?
Um,
Log n?
yeah, BST, yeah, log n.
Okay. So now think, what is the worst case in case of BST?
Worst case in BST.
Right.
Insertion that it is going to be at the uh, end of a
Right.
leaf node, like children.
Right.
Yeah.
Right. So if your binary search tree is just like one line, right? You
Mm-hmm.
are receiving already a sorted number. You receive first number that you made it as child.
Mm-hmm.
You receive second number that is greater than the
Parent.
root. You
Yep.
put it to the right side,
Mm-hmm.
right? Now you get received a third number which is greater than the existing two numbers. You
Root.
will see first number, second number, then you will make it the right child of the right child. Fourth
Yeah.
number is again greater than all the four number.
Mm-hmm.
Again, you are traversing all the four numbers, right?
Got
So
it.
worst case insertion in binary search tree becomes how much complexity? So I'm asking Prashant, what will be the worst case time complexity of adding an element in the binary search tree?
So it should be
I just demonstrated what
yes.
what is the actual worst case,
So O of n in that case.
right?
Yeah, because yeah,
So
yep, yep, it should be O of n.
right.
Okay.
So again, we are in the same problem. Worst case is not handled yet.
What if we keep calculating the median while actually adding to the list?
Okay. How that will work?
So let's say currently we have only one.
Again, you are thinking optimizing the median function,
Okay, you are talking about adding first. Okay.
right?
Uh, what if, let's say, if I maintain an array list of elements 1, 2, 3, 4, 5, so it is O of n here in this case, right? Because I'm not doing any kind of
Mm-hmm.
sorting because I inserted n elements.
Mm-hmm.
And in the median method, I'm then creating a BST from my array list. So worst case will be O of n,
Right.
right? So now beside multiplying, this is going to be an addition towards when we go to calculating the median. So median we can calculate in again O of n, worst time complexity. So it is totally going to be O of n.
You are creating the binary search tree in your.
In my median method, get median method.
Okay.
So let me
So
separate this. Add method is only adding the data to the array list. So the worst
mhm,
complexity here will be O of n, right?
okay.
Now add is completed. For median method, first I'm actually creating a BST from my already created array list. So it is worst complexity is going to be O of n, right?
Mm-hmm.
Now I will use this BST and calculate the median. So the worst
So
complexity
calculate. So calculating the median from a BST, the what that will take,
O of n, worst case.
that was creating the BST.
No, for median also worst case will be O of n. Either if it is balanced or not balanced, worst case should be O of n.
Why? How
Um,
come?
okay, so like when we let me demonstrate through a formula. So if the number of nodes let's say are even, so median in that case
Hmm.
will be actually my pen is not working. N by 2 plus
Hmm.
n by 2 plus 1.
That's when you have a arrays. That's when you have a sorted array. How you will map this formula to a binary tree?
So we can calculate the height of the tree, and that height will be n in this case. Or
Okay.
or
What?
like or what I can do is for this n is number of nodes in the BST.
Right.
So I know that the number of elements are in the array list, so that is the same number which is going to be in the BST. So I know n here,
Right.
so through that
Mm-hmm.
I can do this.
So how you will get the n by 2th index element from the binary tree?
N by 2th node. So okay, so iterating I have to iterate over the BST, but again it is
Hmm.
going to be O of log n. And when I do like the worst to worst case scenario, it is going to be O of n. Again, it is
Mm-hmm.
not getting multiplied. This is like step by step iteration, and it's not nested.
Mm-hmm.
So it is going to be O of n plus O of n, which will be O
Okay.
of n.
Mm-hmm.
So in that case, I am keeping everything separate, calculating the median, and for that I'm getting the nodes which will identify the median. Again, that will be O of n. But after getting
So,
those
basically, you are saying you get a unsorted array. You created a you
BST,
created a binary tree
yes,
in uh,
get median method,
at what is O of n,
yes,
right?
yes.
And then you can create then you can create then you can traverse your binary tree and you
Mhm.
will get a sorted array, right?
No, no, no. I will not get a sorted array. I will traverse the BST, and let's say if the number of nodes are even, then I have to calculate n by 2th node and n by 2th plus 1 node. So these nodes I have to first find out to get the median from BST, not list.
Mm. So, which is your n by 2th node?
So so I can assume, but let's say it is at the end.
Okay,
I'm
okay,
taking the
okay.
worst case.
Maybe I will reframe my question.
Mhm.
Maybe I will reframe my question. When you said you will traverse your binary tree, what kind of traversal you are talking about? You
Uh,
are aware of the different type traversal in a binary tree, right?
yes, yes. So I'm
So which
yep.
traversal you are talking about?
I can use in order in this case,
In order,
or
right? So
yeah,
your in order basically gives you a sorted array
yes. But I don't want anything back. I just want to stop at my expected node.
n by 2th node.
Yes.
Okay, and what it will take to get the n by 2th node?
So worst complexity, like it should be log n, but I'm taking like if in case in logic I'm doing some kind of calculation
Hmm.
which is really worst, so it should be O of n in that case.
Okay. Okay. Okay.
So
Cool.
like
I get it, Prashant. I get it what you're talking about.
actually it's hard to describe, but if
Mm,
there was
I get it. I'm not expecting a solution. Also, I'm just listening you
okay,
because this is just a screening round for your actual interview.
okay,
So 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 writing the code is not required. This is just a screening round.
got it.
Okay.
Okay,
So, Prashant, I would recommend you to go through some data structures like kinds of problem. You learn the different complexities and your sorting algorithms you are not aware of. So,
okay.
I would request you to go all of these things. I think you need a brush up. I think before the interview.
Yeah, yeah, yep,
Am
yep.
I right?
Yeah,
You haven't got the time for
exactly.
brushing up these interview materials thing.
Yes.
Okay, cool. Thank you, Prashant. Do you have any question for me?
No, no, that is all.
Okay,
Okay,
thank you.
thank you so much. Bye bye.